Hello again. This is Math 0465 coming to you from the College of DuPage. And the title of this lecture, which is based on section 1.8 in your textbook, is 2x2 scatter plots. As always, please be attentive while watching this video. The following graph shows high school GPAs and SAT scores for students who apply to a particular university. You can see here it is Trinity University. Each dot represents a student and is color-coded to indicate the student's admission status. They could either be accepted, won't attend, accepted, waitlisted, or denied. So what do the blue dots represent, and where do they seem to be clustered on the graph? Explain why that makes sense. And then the question is, what do the green and purple dots represent, and where do they appear to be clustered on the graph? Explain why that makes sense. Are there any green or purple dots that seem to contradict this trend? And finally, notice that there are blue and orange dots representing students who were waitlisted or denied admission behind some of the green and purple dots. Explain what this means. So please pause the video and give this a go. Let's see. So the dots tended to be clustered around lower GPAs and or lower SAT scores, and they represented denied applications. The others represented accepted applications and tended to be better scores on one or both of these. And there were some that contradicted this trend, but there could have been late applications. And up here also there are also some contradictions or things where this trend didn't happen, but again, there could be extenuating circumstances like late applications. So in this section, we'll focus on making and interpreting scatter plots. When is this the best one to use? How do you set one up, and how do you interpret the results? And you already know how to interpret bar and pie graphs, but not all data is represented with these types of graphs. Sometimes a situation, like the one we talked about there, involves related or paired data, such as height or weight, study times and grades, education and income. And if a situation involves paired data, you may wish to investigate or illustrate a relationship between the two variables. Then a scatter plot is a useful graph to make. So a scatter plot is a graph that shows a relationship between two quantitative variables. The horizontal axis over here represents one variable and the vertical axis represents the other. The data values are plotted as ordered pairs, but the points are not collected as they are in a line graph. So for example, this shows the relationship between horsepower and highway mileage. And you can see that in general, the higher the horsepower, the lower the mileage we get for the vehicle. To make a scatter plot, you need to decide which variable will be plotted on the horizontal axis and which will be plotted on the vertical axis for the given data. Sometimes this will be decided for you, but otherwise you can think about which one it makes sense. And in this one, it made sense to graph the mileage on the vertical axis since it is affected by or depends on horsepower. Now, when two variables are paired, the one that is on the y-axis is called the dependent variable, and the one on the x-axis is called the independent variable. And sometimes you can do this different ways, but often it is clear which way to do it. But this is one of the decisions that you have to make. After you choose which one is independent and which one is dependent, you need to make a scale. And once the axis and scales are determined, you plot each value as an ordered pair on the graph. The value of the independent variable is the first number in the ordered pair, and the value of the dependent variable is the second value in the ordered pair. Okay, so here's an example for us to consider. The following data shows the 2017 gross domestic product and percent of population using online social media for several countries. And so you see a bunch of countries here and the data for the countries. And we have a scatter plot that we get to look at. So here's the scatter plot. And so there's many questions for you to ask, and you could have used different scales. But we want to interpret this. So pause and answer the questions, and we'll see how you did. Let's see. And the biggest thing is that there's an upward trend. The higher the GPA per capita, the more social media tends to be used. Next, you will make choices and create your own scatter plot. Here's the data. This shows salary and years experience. And so you want to draw a scatter plot and figure out what conclusions can you draw from the scatter plot. So please pause the video, make a scatter plot, perhaps using Excel, and go from there. Let's see. So here we plotted these using Excel. We had to enter the data and use the chart making. Again, there are other videos that tell you how to make scatter plots using Excel, but you can see that the more experience you get, the more your salary tends to go up. It's not true in every case, but that's the general trend. So to make a scatter plot, you decide which variable is the independent variable and which is the dependent variable. Draw axis and get a scale. Title the graph, choose minimum and maximum values, and plot the data. And don't connect the points, but because they won't necessarily follow in a line or other pattern, but you can look at the trend and should look at the trend. So here's another example. You want to make a scatter plot to represent this following data. This is time spent studying and what the college GPA is. And it makes sense that the more you study, the higher your GPA is, and that's what this scatter plot illustrates. Now, mathematicians often look at scatter plots to try to find a general pattern that the data seems to follow, even if it's not a perfect fit. And this is called mathematical modeling. So for each of the following scatter plot, think about what the data seems to follow. And again, not every point goes through there, but what is the general trend? Here we have student loan versus years since the loan was incurred. Here we have selling price versus square footage. This is for houses. And we have revenue versus selling price. So please pause the video, figure out how you want to respond, and we'll see how you did. Let's see. Well, the student loan is going to decrease as time goes on because you're paying it off. The selling price, the bigger house you get, the bigger the price tends to be. And revenue versus selling price, up to a certain point, you perhaps make more revenue if you're charging more, but eventually you charge enough so that fewer people buy it and you make less money. So those are the conclusions that you would draw from these scatter plots. It is often useful to predict the shape of the graph from a description of the situation when you don't have any raw data. And so here we have some examples. So A, you save amount of money each month in a non-interest bearing account until you reach your goal, then you leave the account at that balance. This is the average monthly temperature in a given location. This is a population of bacteria that doubles every hour, the height of a ball each second after it's shot from a catapult, the number of days needed to build a bridge compared to the number of workers who are working on the bridge, and the number of students on a college campus who contract a highly contagious flu virus. So you want to do matching of these 6 with these 6. So pause the video, figure out what matches, and we'll see how you did. Let's see how you did. So this is a 6. You've saved money, and then you just leave it there. It's not interest bearing, so it is flat after that. The average monthly temperature, it is cold in the winter, becomes hot in the summer, it gets cooler, and then it goes back the same once you go after a year. So that is 5. Bacteria doubling is going to be this exponential growth curve. The height of a ball, you throw it, it goes up and it goes down. The number of days to build a bridge, the more people working on it, the faster the less time it takes to build it. And the number of students who contract a flu, they start, but more of them get it, and then finally everybody has caught it. So that is how those things match up. Now, this connection chart deals with the ratio of elderly people 65 Years are older to working age people in the United States has been increasing for many years. The ratio, there's more older people. This is a serious problem because working people tend to pay taxes as support services for the elderly. The ratio of elderly to working people is affected by increased longevity and decreasing birth rates. So consider the following scatter plots, which talked about the number of elderly per 100 working. This is over time. And this is the number of elderly in 2015, and so we have that. So how did the United States compare with other countries? Shown in 1960, and again the other countries are shown with the dot. And how's this changed? And what does this mean? And describe what this means for you. So pause the video, make up some conclusions, and we'll compare notes. See how you did. So you got more older people, fewer people pay, so this is not good for Social Security funding. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself because self-care is important. And now more than ever, take care of each other because we're all in this together. God bless you all and looks forward to seeing you soon.